In this video, you will learn about hybrid atomic orbitals. From the last video, what we have seen is by using the valence bond theory to explain how two atoms can come together and form a bond. Those valence electrons, they can share each other, but how exactly do they work? Let's look at carbon, for example. If I show a molecule showing, for example, let's say using ethane as an example, okay, we can see this one, or a molecule look like this. Now, I'm just focusing on the carbon atom, for example. I want to know how this carbon will form together and make a bond with this carbon over here. When we do the electron configuration, we know that as for carbon, carbon has 6 electrons. So the configuration will be over here, 1s over here, 2s and 2p. So 2s here and 2p. So we try to fill up the electrons, 1, 2, 3, 4, 5, 6. So as for carbon, the electron configuration, it is 1s2, 2s, 2 and 2p2. So these are the valence electrons. That's why we said carbon has 4 valence electrons. And if you look at the way that it turned out, the 2s, let's say this is the nucleus, the 2s orbital, it will look like a sphere, but it can have radius with various distance. Okay, if you look at the plot, you can see that the 2s has a shape like this. So the majority will stay here. Let's say the majority is over here. But the 2p orbitals, in fact, according to the calculation, it is like this. It's within the sphere over here. So now, if this is from one carbon and this is from another carbon, so this is the 2s orbital and these are the 2p orbitals, how do they form a bond together? When you combine, should this s orbital touch this orbital first? How does it work? So now scientists come up with an explanation of how they combine together. What they say is the s orbital can combine with the p orbital, and that is called orbital hybridization. That means the s orbital in this case will combine with the p orbital and generate in certain shape that it can form a bond with the other carbon over here. So this carbon will be hybridized. This carbon will be hybridized is orbitals in order to generate the right shape. Okay, so how would that work? Let's look at this molecule over here. So this carbon on the left must be hybridized in certain ways so it can combine with the C. Okay, so as we have seen before, over here, I have one of the 2s orbital and 3 of the 2p orbital, but only 2 of them will be occupied by electron. So totally I can have 1s orbital and I can have 3 of the p orbitals that is available to make the hybridization. Now let's look at this one. How would that arrange in such a way that it will have the right shape in order to form a bond with this carbon? Okay, so after the calculation, what the scientists can come up with a way, look at this one over here. It is actually the same molecule as we've seen. So this one is ethane. So the carbon over here can arrange to have orbital hybridization and form the shape like this. So the yellow shape, it is the hybridized form of the orbital. Now, after it formed the hybridized orbital, it can form a bond easily with another carbon, which also hybridized in the same way. The direct contact on the axis, as we have mentioned before, is called the sigma bond. In this case, how does it exactly work? It uses one of the s orbital and combine with two of the orbitals all together and form the sp2 hybridized orbital. So this one is a hybridized orbital. That's why you see the three branches over here. The trick is, if you use one s orbital and two p orbitals, you will come up with three branches coming out, or the same as three electron groups. Okay, so supposedly I have one s and I should have also three p, because from the energy level we can see that 2s over here and I have three of the 2p. Okay, so one of the s and three of the 2p. Okay, so we have one p left. See, we only spent two of the p orbitals to do the hybridization. What is the leftover? That single p orbital is going to form another type of bond with another carbon, and that is called a pi bond. That's how you see that in a double bond, and you have one is sigma bond and the other one, it is a pi bond. So that pi bond is made of the leftover p orbital, and the electrons are sharing within that space on top and below, not on the axis. Okay, now you can see over here with the yellow color, it is the sigma bond, and when the electrons share around in the pi bond, it actually look like this. So that is how a double bond will look like. The calculation of how the shape of the hybridized orbital look like, that is very complicated. However, to determine how they hybridize and what orbitals they use to hybridize, that is easy. Let's do the following steps. The first step, and probably that's the only step, is to determine, well, to find out how many electron groups or electron pairs. Okay, what do I mean by that? The same as how many branches coming out from that atom. Okay, electron groups, let's look at this nitrogen over here. It has 1, 2, 3, and 4 electron groups. A pair, a lone pair would considered as an electron group. So in this case, with this nitrogen over here, it has 4 electron groups. If we have 4 electron groups, what would be the hybridization? Okay, hybridization should add up to have 4. Okay, so this is what I'm going to do. The possibility will be you either can have one s orbital and one p orbital to hybridize, or you have one s orbital and 2 of the p orbitals to hybridize, or sp3. Can I have sp4? No. Why? Because p orbital, we only have 3 p orbitals. If we have more electron groups, we have to go to the next one, is sp3 and start from the d and on. So sp3d1, sp3d2, until what is the maximum number for the d orbital? 5. And then after that, where do we go? We go to the f. All right, but for this semester, most likely you will see only these 4 types. Okay, now let's see how we can determine what hybridization that is. This total number of electron groups, 4 groups, that will be equal to the sum of the superscript over here. For example, this one, sp, how many electron groups or how many branches should be? We should expect to have 2 electron groups. This one should have 3 electron groups. How do I know that? 1 from the S plus 2 from the P, 1 plus 2 equal to 3. sp3, it would be 1 plus 3 equal to 4. So if I have 4 electron groups, it should be sp3 hybridization. S orbital will hybridize with 3 of the p orbitals. So this one, it is sp3. Let's look at the oxygen over here. How many electron groups or how many branches? 1. Remember, double bond we consider as 1 branch. It's just pointing from this direction. Or 1 electron group over here. So in this case, I have 1, 2, 3. I have 3 electron groups. 3 electron groups. That means I will be having sp2. See, 1 plus 2 over here equals 3. When I have 3 electron groups, I would know that this one it is sp2 hybridized. Okay, let's look at this carbon over here. This carbon has how many electron groups? Let's see, 1, 2, 3. So 3 electron groups. What type of hybridization would that be? sp2 will be 3 electron groups. So this one also sp2. Let's look at this one. How many electron groups? 1, 2, 3, 4. 4 electron groups or 4 branches coming out. So it will be this one if there are 4. So 1 plus 3 equal to 4. So this one will be sp3. Okay, let's try another exercise. I would like to know the hybridization for these atoms. I want to know what type of hybridization. sp, sp2, sp3. What is it? Let's look at this carbon over here. This carbon has how many electron groups? 1, 2, 3, 4. If it has 4 electron groups, that means it must be sp, see 1 over here plus 3. So this one will give us 4, number 4. 4 electron groups. That's why it's sp3. How about here? How many electron groups? 1, 2, 3. 3 electron groups, and therefore it is sp2. So how to check? The one over here, superscript 1 plus the 2 will be equal to the total number of electron groups. What about the oxygen? Oxygen, each lone pair we consider as 1 electron group. So it's 1, 2, 3. 3 electron groups, and therefore it is sp2. How about here? How many electron groups? 1, 2, 3, 4. 4 electron groups, and therefore it is sp3. If you see a triple bond, for example, let's try this one. And what is the hybridization for this carbon? Let's check. How many electron groups? We don't have any lone pair electron here. So 1, 2 electron groups, and therefore it is sp. Because I have the 1 here, I have the 1 here, and add up to be the number of electron groups.